We're asked to consider the circuit below. Notice how the circuit has an 18-volt source flowing in the counterclockwise direction, which is the same direction as the current I, which will be important later. Notice how the circuit has 3 resistors with the resistance of 2 ohms, 4 ohms, and 2 ohms. Let's label the resistors R sub 1 through R sub 3. For number 1, we're asked to determine the total resistance of the circuit. Because the current only has one path, to find the total resistance, we sum R sub 1 through R sub 3, which gives us 2 ohms plus 4 ohms plus 2 ohms, which is equal to 8 ohms. The total resistance of the circuit is 8 ohms. For number 2, we're asked to determine the current I. To do this, we use Ohm's law, which states the voltage V is equal to the current I times the resistance R. And because the current I is in the same direction as the flow of the volts, we use positive 18 for the volts. If the current I was in the opposite direction of the volts, we would use negative volts. Instead of using the equation 8I is equal to 18, let's work our way around the circuit to set up the equation, which is what we will do when we have a more complicated circuit. So starting with resistor 1, I times R would be I times 2, or 2I, plus for R sub 2 we would have I times 4 ohms, or 4I, and then plus for resistor 3 we would have I times 2 ohms, or 2I, equals 18. Combining like terms on the left, we have 8I. Again, this 8 here is the total resistance of 8 ohms, equals 18. Divide both sides by 8. Simplifying, the current I is equal to 18/8 amps, which simplifies to 9/4 amps. For number 3, we're asked to determine the voltage across each resistor. To do this, we'll use Ohm's law again, V equals I times R, where now R is going to be R sub 1, R sub 2, and R sub 3. So the voltage across resistor 1 is V sub 1, which is equal to I times R sub 1, which is equal to 9/4 times R sub 1, which is 2 ohms, which gives us 18/4, or 9/2 volts. The voltage across resistor 2, V sub 2, is equal to I times R sub 2, which is equal to 9/4 times 4 ohms, which gives us 9 volts. And then the voltage across resistor 3 is equal to I times R sub 3, which is 9/4 times 2, which we already found to be 9/2 volts. Now if we stop here for a moment, notice how if we sum V sub 1 through V sub 3, we do get 18 volts, which is the same as the total voltage source. Let's go to the next slide and answer number 4 and number 5. For number 4, we're asked to determine how much power is absorbed by each resistor. The power absorbed by resistor 1 will be P sub 1. And we can use any of the 3 formulas shown below. P equals I squared times R, P equals V squared divided by R, or P equals V times I. I'm going to go ahead and use I squared times R, except for P sub 1 we will use I squared times R sub 1. Well, I squared is equal to the square of 9/4 amps, and then R sub 1 is 2 ohms. The square of 9/4 is equal to 81/16 times 2 is 81/8, and the units here would be watts. P sub 2 is equal to I squared times R sub 2, which is the square of 9/4 times 4, which gives us 81/4 watts. And P sub 3 is equal to I squared times R sub 3, which is the square of 9/4 amps, times R sub 3, which is 2, which we already found for P sub 1, which is 81/8 watts. And then for number 5, we're asked to determine how much power is delivered by the battery. Again, we can use any of the 3 power formulas shown below. Let's go ahead and use the formula P equals V times I. So the total power delivered by the battery, again, is equal to V times I. V is 18 volts, and I we know is 9/4 amps, which gives us 81/2 watts. Before we go, to double check our work, if we sum P sub 1 through P sub 3, the total watts should be the total power given by P. And let's quickly check this. This does verify our work. The sum of P sub 1 through P sub 3 is equal to 81/2 watts, which is the same as the total power delivered by the battery. I hope you found this helpful.